Okay, so this example says to solve and graph the inequality. And then it says use the graph to give a number that satisfies the inequality. Step 1 is to decide if it's an and or an or inequality when we want to solve this. This part's easy. If it's or, it will say the word or. Okay, we already looked at those. Otherwise, when the variable's in the middle of the two here, that's an and inequality. So this says that negative 10 is less than or equal to negative 4x minus 18, and negative 4x minus 18 is less than or equal to 30. So that part's pretty easy. Then we got different steps to solve, okay? If it's an and inequality, you solve both sides, okay, and you solve it together. And we'll show you how to do that. If it's or, you're going to solve each part separately, okay? So here's what I mean by solving it together. Let's pretend that this inequality right here was the only one we had. The first thing we would do is solve this inequality. Well, first is we would change it to addition, correct? So the first thing we're going to do is change this inequality to addition. So we're equal to negative 4x plus negative 18 is less than or equal to 30. Okay? Now think about this. We got to get the x by itself. Okay, normally we get it on a side by itself, but now we want x in the middle by itself. So the very first thing I have to do is get rid of this pesky negative 18 right here. So I got to add 18. Now here's the trick. Okay, I have to add 18 here to cancel it out. Normally we say we add it to both sides of an equation or both sides of an inequality, but I've got two inequalities I'm solving at once. So I'm going to add it to every part. I'm going to add it here and over here. So I added it to the left, I added it in the middle where I want to cancel, and I added it to the right. So 3 different places. Well, these cancel. Over here, negative 10 plus 18, that's 8. In the middle we canceled out. And over here, 30 plus 18 is 48. Now, I need to get x by itself, so I would divide by negative 4. And again, I'm going to do that everywhere. Okay, well these cancel. Leaves me with x in the middle. Over here I got 8 divided by negative 4, that's negative 2. Now notice, I divided by a negative right here. So remember what happens to the sign when I divide by a negative? I have to flip this around. Okay? Then over here, I'm taking 48 divided by negative 4. That's negative 12. And again, I divided by a negative, so I have to flip the sign. Okay? So there's my solve part. Now I've got negative 2 is greater than or equal to x, which is greater than or equal to negative 12. Now I need to graph it. Now remember, this is an and inequality. So normally my shading will meet in the middle. Okay? So let's go ahead and see. Now they're far enough apart, they're 10 apart. So I'm going to count by 2's here. Again, we got to start on the low end. Negative 12 is my low end. We got to go past that. So negative 14, negative 12, negative 10, negative 8, negative 6, negative 4, negative 2, and then we got to go past 0. Okay? Oh, we can start over here, that's fine. I've got a closed dot at negative 2. And I've got a closed dot at negative 12. Now, don't get in the habit of just assuming because it's an and inequality, the shading is going to go in the middle. Okay? Let's actually check this out. Do the shading the right way like you're supposed to. So this says negative 2 has to be bigger than or equal to the numbers we're shading. So if negative 2 is bigger than the numbers we're shading, that means that from negative 2 we need to shade to the left. And this says the numbers we shade are bigger than or equal to negative 12. So that means from negative 12, I should shade to the right. And right in the middle here, notice how they're going to overlap. Okay? That is our solution region, right in here. So we'll make that nice and dark. So that means any numbers in the middle should be solutions of the inequality. Well, our example asked us to use a graph to give a number that satisfies the inequality. So any number in here in the middle satisfies it. Just because I'm Mr. Ayers and I'm Mr. Math Man, I'm going to pick a number that's not even on a number line, like -6 2/3. Okay? This is a place where I'm going to give you a chance to be creative. Okay? You can pick whatever number you want to as long as it is in between here in the solution region. If you wanted to pick -4.9 repeating, go for it. Okay? If you want to pick pi, or sorry, negative pi, -3.14, whatever. Okay, that would be another one that you could pick. You could be creative with this. It's up to you. Okay? Alright, let's go on to more examples. Okay, again, here we are, same kind of problems. So let's solve them. Again, pick if it's and or first. This one's or, so we're just going to solve these separately. Okay, so I'm going to just solve the two inequalities separately here. So I'm going to first solve this left one. So I'm going to do a -6 to both sides. And -3 minus 6 is -9 plus an x. Okay? Or, I'm going to solve the other side now. Multiply by 3 on both sides. These cancel. I get -x is greater than 12. Now I've got to divide by -1 on each side. That cancels the negatives. I have to flip the sign. Okay? So I've got -9 is less than x, or x is less than -12. So my numbers I have to go between are -12 and -9. So I'm going to start at -13, -12, -11, -10, -9, and here's -8. Okay? Well, I got an open dot at -9 and an open dot at -12. Well, this says I have to shade numbers that are bigger than -9. Okay, so I'm going to have shading that goes out this way. And this one says I have to shade numbers that are less than -12. So from here I'm going to have numbers that go this way. So I'm going to go ahead and shade those then. And again, solution region for an OR inequality usually doesn't meet. Okay? Use the graph to give a number that satisfies the inequality. So for OR inequalities, any number that's shaded works. Okay? So -8 would work, because it's in the shaded region. -14 would work, even though it's over here in a different shaded region. Again, you can pick whatever number you want, as long as it's in the shaded portion. Alright, and we got two more examples. Alright, so another example. Solve and graph the inequality. So here we go. Alright, so first thing we need to do, change subtraction to addition. Becomes a -3x. Okay, we need to take away 5 from all three parts so we can cancel this out. That cancels, leaves us with -3x in the middle. -10 minus 5 is -15. And -13 minus 5 is -18. Now we're going to divide by -3 everywhere. This cancels. -15 divided by -3 is 5. Makes us flip the sign. And -18 divided by -3 is 6. And makes us, again, flip the sign. So, now we need to graph it. Oh, we got 5 and 6, so that should be pretty easy. So we'll just go 4, 5, 6, and 7. Okay, so we need an open dot at 5. Closed dot at 6. Now, when I'm reading this again, this says that 5 has to be bigger than our numbers. So phi is bigger than our numbers, then our shading should go this way. It also says that our numbers should be greater than or equal to 6. Okay? Well, remember, this is an and inequality. And inequalities have to have numbers that are solutions of both. Well, I can't have numbers that are less than 5 and greater than or equal to 6. So, there's no region, no solution region. That means that there is no solution. So we got no solution to this one. Because it's an and inequality without a place where the shading crosses. So no numbers can be a solution of each one. No solution that inequality. Alright, let's try one more. Okay, so again, solving and graphing. So let's go ahead and solve these here. So we're going to subtract 1. Gives us 2x is greater than 8. Divide by 2, divide by 2. And x is greater than 4. Or subtraction to addition. We need to add 2 to both sides to get rid of that. And divide by 5. And we get x is less than or equal to 5. Okay? So again, we're going to graph this. Get on both sides of the numbers here. We need an open dot at 4 and a closed dot at 5. Okay? Well, x is greater than 4, that's this way. Or x is less than or equal to 5. That's got to go this way. Remember, it's one or the other that are solutions of these. Well, if it's one or the other, I've got an arrow that goes here and goes all the way this way forever. So everything over here is a solution, and everything over here is a solution. That means that I've got an or inequality where the shadings intersect. When I have an or inequality where shadings intersect, that means all numbers are solutions. Okay? All numbers. So if I've got an or inequality where shadings intersect each other, that means all numbers. Well, that should make sense because every number is bigger than 4 or less than or equal to 5. Okay? Every single number, doesn't matter what it is, has to be bigger than 4 or less than or equal to 5. So that should make sense. Alright, those last two examples are just more for fun. You won't see any of those on your assignment, or shouldn't anyway. But they are good to know. Alright, happy homeworking.